Hello students, in today's video we are going to continue chapter 1 method. In today's video we are going to cover these topics: formation of meniscus in liquids contained in a narrow vessel. Second, explanation of liquid pressure on kinetic model. Third, explanation of gas pressure on kinetic model. Fourth, effect of reducing the volume of a gas on pressure in a closed vessel. Then explanation of heat conduction on kinetic model of matter. And the last one, explanation of heat convection on kinetic model of matter. So let's start with the first topic, that is formation of meniscus in liquids contained in a narrow vessel. Before explaining this topic, what is meniscus? We know the meaning of all words, but we don't know what is meniscus. So, what is meniscus? The formation of curved surface by the exposed surface of a liquid contained in a narrow vessel is called the meniscus. Here, can you see? There is a vessel. Here we can see curved surface. Second one, a vessel is there. In that we are getting liquid, it is filled with the liquid, and there is a curved surface. So this is meniscus. So formation of meniscus in liquid contained in a narrow vessel. About this we are going to study. Remember, there are two types of meniscus: convex meniscus and concave meniscus. This process of convex meniscus and concave meniscus based on the force of cohesion and force of adhesion. Force of cohesion and force of adhesion we have studied in last video, but let me define it one more time. The force of attraction between similar kind of molecules is called the force of cohesion. When there is force of attraction between similar type of molecule, that is force of cohesion. And when there is force of attraction between dissimilar or different kind of molecules is called the force of adhesion. So this process of convex meniscus based on the force of cohesion. Process of concave meniscus based on the force of adhesion. Now, see here in this you can see convex meniscus. It has been observed that in case of mercury, here in this vessel we are using mercury, a convex meniscus is formed. It is because the molecules of mercury have strong force of cohesion. Means same type of molecules attracts molecules of mercury. But no force of adhesion. Force of adhesion means that attraction between mercury and this vessel. These are different kinds of molecules, but there is no attraction. There is no force of adhesion. There is only force of cohesion, means attraction between the molecules of mercury. This is the reason the molecules of mercury near the exposed surface are pulled inward. They are acted upon by unbalanced forces. In order to neutralize these forces, the molecules of mercury near the exposed surface realign themselves and take convex shape. Now about concave meniscus. It has been observed that the most of liquids such as water, alcohol, they form a concave meniscus, means this type of. Force of adhesion with glass surface means attraction between different kind of molecules, attraction between the molecules of glass and molecules of this liquid. Different type of molecules are there. There is attraction, that is why this layer goes upward direction, this corner layer, and it makes a shape of concave. These liquids have far stronger force of adhesion with glass surface and a weak force of cohesion, means there is no force between these molecules of this liquid. Molecules of same kind of. The liquid tends to rise up along the glass surface. This in turn creates that shape of concave meniscus. Explanation of liquid and gas pressure on liquid kinetic model. Students, these are two topics: liquid pressure on kinetic model and gas pressure on kinetic model. Why we are taking it that in combined I am explaining, because we can compare it. Liquid pressure and gas pressure we can compare here. So let's talk about the liquid pressure on kinetic model. This one is the diagram of liquid pressure. These are the molecules. This is a vessel in which liquid is there, and these are the molecules of liquid. We know that molecules of liquid and gas moves. So these molecules are moving in a vessel and exerting some pressure on the sides of the vessel. This is the pressure applied by the molecules to the side of the vessel. Same in the gas pressure, there is a vessel which we are using here. These are the molecules of gas which are moving all around in all directions. So this is the pressure exerted by the molecules of the gas on the side of the vessel. Let's start with the explanation of liquid pressure on kinetic model. The molecules of liquid in a vessel are not stationary but move about randomly in all possible directions. In doing so, the molecules of liquid strike against the side of containing vessel and hence exert some specific force. This force exerted per unit area on the side of containing vessel is called the liquid pressure. Then explanation of gas pressure on kinetic model. The molecules of gas contained in a closed vessel are not stationary. They move about randomly in all possible directions. In doing so, the molecules of gas strike against the side of containing vessel. These molecules are striking and hence exert some specific force. This force exerted per unit area on the side of the vessel is called gas pressure. Effect of reducing the volume of a gas on pressure in a closed vessel. So here we are reducing the volume of gas. So what the effect gas pressure will get? Imagine a cylinder. Here you can see this diagram. There is a cylinder in which there is a piston and inside it there is the air. Volume of air is 20 centimeter cube. Again, when we are applying force on this piston, volume of the air decreases we are getting the volume is 10 centimeter cube of air. This is the needle, diffracting needle. By this we can measure the pressure. So let's start. Imagine a cylinder filled with air and fitted with a meter to record the pressure. This is meter to record the pressure of air and an airtight piston. Let the volume of the enclosed gas is 20 centimeter cube and the pressure is 760 centimeter of mercury. This is pressure is 760 centimeter of mercury. Let the gas be compressed when we are applying force. Let the gas be compressed by applying force F such that its volume decreases to 10 centimeter cube. It is observed that reading on the pressure meter will be 1520 centimeter of mercury. Here in this case we are getting pressure 1520 centimeter of mercury. Pressure becomes double by the initial pressure. Initial pressure was 760. After compressing this air, pressure is 1520. It is almost double. Why? Reason and the process behind it. From this discussion we get that it can be concluded with a decrease in volume of the enclosed gas, its pressure increases. Why does this happen? Reason. When the gas is compressed, the half its initial volume, the number of molecules per unit volume of the gas also becomes double. Initially, molecules was like this. When we are applying force on the piston, when we are compressing it, that time number of molecules are same, but being double means like this. These are the compressed molecules. Double the number of molecules strike against the side of the enclosed vessel. Here number of molecules are double, which are striking on the surface of the vessel or the cylinder. Here number of molecules are single when we are not compressing it, thereby exerting double the amount of force, as the force acting per unit area on the sides of the containing vessel doubles. Therefore, the pressure of the enclosed gas doubles. This is the reason, because force struck by the molecules is double in this case on this specific area, on this specific area, on this specific area. Here number of molecules are single, that is why pressure is less. If the volume of the enclosed gas is double, then the number of molecules per unit volume of the gas will become half. As half the number of molecules strike against the sides of the enclosed vessel, therefore they exert half amount of force, as the force acting per unit area on the sides of containing vessel becomes half. Therefore the pressure of enclosed gas becomes half, that is 760 centimeter of mercury. It is half. Then B. Explanation of heat conduction on kinetic model of matter. First of all, what is conduction? We have to understand the process of conduction. the conduction is the mode of transmission of heat energy from one atom to another atom in the direction of lower pressure, means higher pressure to lower pressure, without the actual movement of atoms from their mean position, is called the conduction. Means in the process of conduction, heat energy transfers from one atom to another atom. Atoms does not transfer. All the atoms will be on their own position, mean position. Atoms will not be transferred. Only the heat energy will transfer. And this transfer of heat energy will be from higher pressure, high pressure to lower pressure, high temperature to lower temperature. Let's understand this process of conduction using an example. Suppose this is an iron rod. There is a Bunsen burner which provides heat. When solid, in case of solid, we are using iron rod, is heated from one end. This is heated from one end. Heated from one end in fire, its atoms gain heat energy. This area of the rod will be hot because of heat energy. This area is getting heat energy from the Bunsen burner. And the gain of heat energy by the atoms increases their kinetic energy. Because of hotness, atoms will get the kinetic energy. They vibrate about their mean position with more amplitude. In that case, these energetic atoms strike against the neighboring atoms. This area is being hot, so these vibrating atoms will get the kinetic energy and will start vibrating, and these vibrating atoms will provide heat energy. These atoms will not vibrate, these atoms will not move. Heat energy will provide heat energy to its neighboring atom. This atom will get hot. Again this atom will get kinetic energy, will start vibrating, will provide heat to the next atom, neighboring atom. This process will be continued till this end. Means this atom is being hot, will start vibrating because it is getting kinetic energy. It will provide heat energy to its neighboring atom. Again, now this atom is hot, will get kinetic energy, start vibrating, and will provide heat energy to neighboring atom. Like this process will be till the end of the rod. Means will provide heat energy to neighboring atom. Okay, repeating this point, these atoms are not moving. Heat energy is being transferred from one atom to neighboring atom or the another atom. And one more thing which we are observing by the definition, this flow of temperature is being higher temperature. Initially these molecules were hot. They are giving heat energy to these cold atoms. So heat is transferring from higher temperature to lower temperature. So these 3 points you have to remember in case of conduction. The transmission of heat energy from one atom to another atom or the neighboring atom in the direction of higher pressure to lower pressure without the actual movement of atoms. Atoms are not moving. Only heat energy is being transferred. This is the process of conduction. Explanation of heat convection on kinetic model of matter. Last topic was heat conduction. This topic is heat convection. Okay, let's understand the phenomenon of heat convection. Due to the particles of a medium, this phenomena due to which particles of a medium actually move towards the force of heat energy, and and then on absorbing heat energy move away from it, thereby making a space for other particles of medium to move towards the source of heat is called the convection. Remember, let me understand the difference between convection and conduction. In conduction, we got that atoms were not moving, only heat energy were transferring. But in case of conduction, atoms moves from one place to another after getting heat energy. This is the only difference between the heat convection and heat convection. In heat convection, atoms will move from one place to another place after getting heat energy. In case of conduction, atoms will not move. Okay. Using an example, heat convection. When a liquid contained in a vessel, this is a vessel contained liquid, using Bunsen burner, we are providing heat to this vessel, to this liquid. So, when a liquid contained in a vessel is heated from the base of the vessel, then the particles of liquid in the region of heat, means these particles, on the region of the heat source absorb heat energy. Initially, these particles will get heat energy because these particles are in direct contact with the Bunsen burner. Then, the heat energy absorbed by the particles increases their kinetic energy. Getting heat energy, kinetic energy will increase of these particles. They move more fast. These energetic particles move away from the source of heat and rise upward. These particles will be away and these particles will rise upward. Now this region is free. These particles which are colder than these molecules will take place of these molecules. Means in this case atoms are moving after getting heat energy. Initially these particles are being hot, getting heat energy, will get kinetic energy. Molecules will get kinetic energy, start vibrating. These molecules will move towards the upward region. Now this place, this region is free, empty. So these molecules will take place of this one, this region. This results in the fall in pressure. To equalize the pressure, the particles of liquid from the colder region, this is the colder region, sink down. They move towards the source of heat. This in turn gives rise to convection currents. Already we have studied about the convection current in this process, that which particles gets direct heat energy start moving and will get kinetic energy, will move towards the colder region, and the molecules which are colder will take place of this area which is in direct contact with the Bunsen burner. This process creates a current. That current is called the convection current.